Welcome in. Today, we're diving into a genuinely fascinating, hardcore coding philosophy. We're talking about the strict, uncompromising, and honestly brilliant world of Tiger style. This is the core philosophy driving Tiger Beetle, which is a database built specifically to handle massive-scale financial transactions. If you're the kind of person who loves figuring out how systems are engineered to literally never break, you are going to absolutely love this explainer. Let's get right into it. Okay, so let's take a quick mental trip back to, say, 2020. The whole LLM craze hasn't completely taken over the world yet, right? Rigorous coding standards are still top of mind. But flash forward to today, and we are living deep in the era of vibe coding, prompt engineering, and endless agent loops. We're all enjoying this incredibly fast, kind of easy life in software development. Well, Tiger Style operates on a totally different wavelength. Their slogan, "Do the hard thing today so tomorrow becomes easy." You gotta remember, Tiger Beetle sits at the absolute core of modern financial systems. In their world, a tiny bug isn't just a glitch on a web page. It means duplicated transactions, corrupted balances, and real, actual money lost. The stakes are just off the charts.
So, here's our roadmap for today. First, we'll break down the anti-vibe philosophy. Then we'll look at designing for absolute safety. Third, built for the CPU. Fourth, the single-threaded secret. And finally, we'll wrap up with their zero technical debt policy.
Section 1. The Anti-Vibe Philosophy.
Think about most modern development frameworks we use today. Stuff like React, for instance. They almost always prioritize developer experience, right? We naturally gravitate toward tools that are smooth and easy to pick up. Well, Tiger Style brilliantly flips this modern priority pyramid completely on its head. Developer experience? That is placed dead last. When you're building serious financial-grade software, step 1 absolutely has to be safety and correctness. Step 2 is performance. And only after those two massive guarantees are totally locked down do they even entertain the idea of developer experience. It's a total paradigm shift.
Moving right along to Section 2, designing for absolute safety.
To achieve that safety, every single component, queues, buffers, even basic loops, has to have a hard, explicit limit. This keeps memory usage completely predictable. And that brings us to one of my absolute favorite rules in Tiger Style: no dynamic allocation after initialization. This is actually so fascinating. When the system starts up, it calculates exactly how much memory it's going to need based on your configured limits, and it allocates the whole shebang right then and there, before the main event loop even starts. The code processing the actual financial transactions, it never repeatedly asks for or frees up memory. By doing this, they entirely dodge the latency hits that normally come from a memory allocator during active processing.
The core reason behind this super strict rule all comes down to fragmentation. See, when you have a long-running, low-level system that's constantly grabbing and releasing chunks of memory, things get messy. You get external fragmentation, which is when you might technically have enough free memory overall, but it's scattered across tiny, unusable regions. Then there's internal fragmentation, where the allocator gives you a bigger block than you actually asked for just to meet alignment rules. Now, neither of these will necessarily crash your program immediately, but they make memory usage wildly unpredictable. Banning dynamic memory allocation is just a really elegant way to prevent these issues from slowly poisoning a system over time.
Then there's the fail fast rule. Tiger Style mandates an average of at least 2 assertions per function. Now, if you don't use assertions a lot, you might think of them as just annoying interruptions. But here, they're a crucial, literal, protective shield. They enforce all those rules that the type system simply can't catch on its own. If an assumption about a financial balance suddenly isn't true anymore, the program fails immediately. It intentionally crashes, right on the spot, rather than limping along and silently corrupting critical financial data.
Let's move into Section 3, built for the CPU. I really want to give you a visceral sense of scale here with some wild trivia. A modern CPU core running at 3 GHz churns through roughly 3 billion cycles every single second. 3 billion! To put that into perspective, adding 2 integers that are already sitting in the CPU's registers takes about 1 cycle. It is just blindingly, incomprehensibly fast.
But check out the massive difference in cost between memory layers. Grabbing data from a register, like we said, basically 1 cycle. Reading from the L1 cache, maybe 4 or 5 cycles, not bad. But fetching data all the way from main memory, your RAM, that can cost you anywhere from 200 to 400 cycles, depending on your hardware. In the time it takes to pull just one single value from RAM, your CPU could have literally executed hundreds of math operations. Instead, it's just starving, agonizingly waiting for that data to show up.
Because of this massive penalty for hitting RAM, Tiger style forces you to write obsessively cache-friendly code. You push your if statements up and push your for loops down into specialized functions so branches are evaluated once rather than over and over for every element. You explicitly size your data to fit snugly into cache line boundaries. And crucially, you avoid any unnecessary copying or serialization. Every single time you copy memory or translate data formats, you're burning precious memory bandwidth. By keeping data compact and perfectly aligned, they keep the CPU constantly fed with information that's already sitting right there in the ultra-fast cache.
Section 4. The single-threaded secret.
So financial workloads inherently have incredibly high contention. Imagine thousands of transactions all trying to update the exact same popular bank accounts at once. Those updates have to be processed in a very strict, defined order. If you try to solve this just by throwing more threads at the problem, you don't actually get more speed. What you get is massive synchronization overhead, a nightmare of complex locking delays, and a huge spike in cache traffic. It just bogs everything down.
So how do they handle this? It is absolute architectural genius. They take the tasks that can genuinely run concurrently, things like disk reads and replication, and they run them concurrently. Before executing a batch of transfers, Tiger Beetle figures out exactly which accounts are needed and prefetches them directly from the disk. But, and here's the secret, once that data is actually available, the accounting hot loop, the actual logic that moves the money, runs synchronously and sequentially on one single core. No locks, no waiting, no context switching. Just pure, uninterrupted processing speed.
But to make that hot loop perfectly reliable across multiple machines, you have to strictly control your external interfaces. You can't have a replicated state machine just casually ask the operating system what time it is, right? Because two different replicas might get slightly different answers. That's non-deterministic, and it's a huge problem. Instead, they convert things like time into a deterministic input. The primary server grabs the timestamp, stamps the operation, and then every single replica uses that exact same value to execute the state transition. This ensures every machine stays in perfect, exact harmony.
Finally, we've made it to Section 5, Zero Technical Debt Policy.
Look, in most software projects, when you stumble across some janky code or a dangerous architectural flaw, what happens? It gets tossed onto a backlog with a vague promise that, hey, somebody will eventually come back and fix this. Tiger Style outright rejects that entire concept. Their policy is absolute. Known correctness or architectural problems must be fixed immediately. Zero exceptions. You simply cannot knowingly build brand new features on top of a buggy, poorly understood foundation. It's just not an option.
Which brings us to the end of our explainer today. And I want to leave you with a question to really chew on. In our modern era of agentic loops and insanely rapid LLM-assisted coding, are you unknowingly building your future on a shaky foundation of technical debt just to have an easy life today? Tiger Style shows us exactly what happens when you commit to doing the hard thing today. You gain extreme performance and unmatched reliability tomorrow. I hope this deep dive sparks some curiosity about how you structure your own projects. Thanks so much for learning with me today, and I'll catch you in the next explainer.